Hello everyone, this is the algebra lesson for April 20th. So April 20th, and we're going over the last section of chapter 9, which is 9.6, dividing polynomials. Before we get into it, I just want to go over some housekeeping, then we'll say some prayer, and then we'll get into our lesson. But starting April 20th, you should be receiving a packet that has a quiz for 9.5 and 9.6. That finishes the chapter for chapter 9. So I'm also sending home a test for chapter 9. Now, today's lesson's over 9.6. April 21st is when I'm going to take your test and piece by piece go over your test and say, this problem comes from 9.1. Go back and look at it. This problem comes from this. Go back and look at it. As well, as you all know, each time I do a video, I go through examples, I go through problems and say, this looks like one on your quiz. This looks like one on your test. So you'll need to go back and hopefully mark those. So when you're doing your test and doing your quiz, you can go back to your book and be able to find all that readily for you. So this week looks like this. Today's lesson's on 9.6. Tomorrow's lesson is going to be very brief. I'm just going to go over the test and what section you can find this, the problem for. Then on Wednesday and Thursday, you will not have a video because I'm giving you 2 days to go ahead and complete your test. And then on Friday, we are going to pick up and start chapter 10.10, which is all on factoring. So we'll start that on Friday. So hopefully you guys, I know some of you last week were still working on chapter 8. Hopefully you've got chapter 8 finished and you started working on chapter 9. Chapter 9 was a rather short chapter. I think hopefully some of you all found it easier. Because we were adding, subtracting, classifying polynomials, multiplying polynomials. Today, 9.6 is probably your most difficult section of that. So it's probably going to be long. You're just going to have to be patient. If you don't understand something and you can't figure it out from your book, then encourage your friends to watch videos. Right? Watch videos, because I am going to be looking for some work on this test and quizzes. I just don't want answers. All right, so let's take a quick, brief word of thanks, giving, prayer, and supplication, and all kinds of different things to the Lord. So, Father, we praise you and we thank you for this beautiful day you've given us and for another opportunity to learn about you and to learn about creation through mathematics. And Father, I just pray that you'll grant clarity, grant wisdom and understanding to me and to everyone who is listening so we can understand and get through our algebra for this term. And Father, please grant the wisdom of heaven to not only us, but to the authority figures of our world. And I just pray for healing and I pray for mercy. We love you in Jesus' name, amen. All right, guys, so we're going to start with a lesson opener in dividing polynomials just to get you back in the idea of how do I divide things. And the most important thing I want to talk to you about as we're starting to divide polynomials is that when you're dividing and when we're doing what's called canceling out, the only thing you can cancel out, and this comes really, really important in the next chapter, is you can cancel out common factors only. Common factors only. You're going to see that here, right here, and especially when I have another example just to say cancel out common factors. So let's start with this one right here. So, and you can just look at what we're doing. What we're going to do is we're going to do the actual division. So if you look at the actual division, I'm dividing 6 by 2, and that becomes 3. And then those things right there are factors, and they're common. This is one term, this is one term. That's what I'm looking at, that term. Do I have something common? So I do have something common right there. That would cancel out. That becomes, so my answer, so these two x's have canceled out. X is divided by x, or you can think of the little exponent of 1 as being subtracted by the exponent of 1. We could have also written it out like this, 1 minus 1. That becomes 0, so anything to the exponent of 0 is 1. So the x's are gone. The x's cancel out. So let's look at this next one just to get this back in your brain. So technically this would look like this, 6 minus 2, right? So if you can remember, 2 is being subtracted from 6. This was what some of chapter 8 was about, but we just weren't together, so I'm trying to really reiterate it. This is going to end up being x to the 4th power. All right, so we've gotten that far. I'm just checking myself as we go on. Let's look at what happens over here. So here, I'm going to go up here to 3. Here, I'm basically, that's telling me I'm multiplying all of this by 1/3. Or another way to think about that is we could distribute this. You can use distributive property with this as well. So let's do that, and I think it makes your life easier. I'm going to divide the 3x by 3. I am going to divide that 12 by the 3. Or technically what I did is I multiplied that 1/3 to 6x. I multiplied that 1/3 to 12, and I ended up with that. Now I can go ahead, go through, and do the division. So 6x divided by 3, I'm going to go ahead and I'm going to divide my number. 6 divided by 3 is going to be 2, but the x is still there, so I'll keep the x. Then 12 divided by 3, that will become 4. So we got that far. Same thing here. I'm going to basically multiply this all the way through by 1 over x, just like I did up here. See here, the 3 stayed at the bottom. Well, the same thing's going to happen here. 4x squared is going to be divided by x. 7x is going to be divided by x. Now, I can go through and I can do some canceling out. So technically what's happening here is 2 is being subtracted by that 1. Remember, that's with my exponents. The 4 is going to stay there, so that's going to become 4x. Technically, what's happening here? This, you could say, okay, just like we did right over here, my x's are canceling out. Or what's happening is that 1 is being subtracted by 1, which becomes x over the 0 power, which is just going to be 1. So that ends up, so that 1's right there, kind of multiplying with the 7, which is simply going to make it just the 7's left. That's it. Oops, scoot that over. Here is a really, really common error. And they put this big red letters in my book, so let's have a walk down here. The common error is right here. Right here. Is what would you want to do when you immediately look at this? What you would like to do is you would like to go ahead and cancel that out, right? Isn't that what you feel like? All right, you got 3x here, you got 3x here, let's just cancel that baby out. That's not what's going on though, guys. Technically, that has to be a common factor. So it works out if you do like we did over here. So if it was set up like a problem over here, you would say, I'm going to distribute that. You have to do the same thing here. Even though this is what it looks like, you have to say, okay, x squared, I'm going to divide that by 3x. This 3x, I'm going to go ahead and divide that by 3x. Because this gives you a much, much different answer than what you would have ended up with, all right? So what you wanted to do is just go cancel that out, x squared plus 1, done. That would be wrong. Now let's look at what you're doing. I'm going to erase some of this so it may not get into our problem as we look at it. So now let's look at what we're doing. So technically what I've got going on here is I have, okay, they're like canceling out weird stuff, and I'm going to look at it. So let's look. So technically, what's going on right here is you have 3 isn't going to be able to cancel out with anything. It's going to hang out. My x basically has a 2 and then minus a 1, right? A 2 minus a 1. So the x is going to stay right there. So think about what's happening, guys. That x is going to stay up there at the top. X is going to stay right there. The x down here is gone. See how that's a whole lot different than what you were trying to do right up here? Now look what happens. You got 3x divided by x. So you got 3 divided by 3. That's a 1. Technically what's happening to your x's, I've got 1 minus a 1, which would end up being x over 0, which would become a 1. So this is a 1, this is a 1, or you could just say 3x divided by 3x. It's the same thing. That's going to be a 1. See how much different that is from you saying, done is going to be this. I am just so brilliant at this stuff. No, that is wrong. Very, very wrong. You have to use distributive property. Make sure each of those factors are being divided, because this is a much, much different answer than what you would have gotten just by saying, all right, my common sense is telling me this. So what's the important thing? Common factors cancel out. Or technically, I'm going to have, if it's in a term, I'm going to have to take every single one of those things and divide it. And that's what example 1 looks like. I'm going to go through example 1 and example 2. Then we're going to cover some information, and we'll start on your homework. My cart is always in the way. So let me move that over, and let's go over here to example 1. Mark example 1 as a very similar quiz question. So you probably can't see this, but example 1 is written out for you. So it says to divide 12x squared plus 20x by 4x. I just put the division symbol in there because I'm lazy. I don't want to write everything. So let's think about how you're going to write this. You could have just put a big line over there and put 4x there. But now we know that 12x squared is going to have to be divided by 4x. And the 20x is going to have to be divided by the 4x, right? This is a distraction, so I'm going to move that out of the way too. We'll go back and do that one. So let's look at what we do. I'm going to divide 12 by 4. That's easy, right? That's going to be a 3. What happens with my exponents? I have a 2 minus a 1, so this one is gone, right? So both the 4 and the x are gone. What am I left with? The 3x up at the top, technically, if you can kind of see what you're doing. Now, let's go over here. You could go ahead, so my 20 is divided by the 4, that's a 5. What's happening to the x's? X up here, you could almost consider it by itself. If I had x divided by x, it would be 1. That's what's happening here. Those x's are canceling out because they're common factors. Those are common factors, right? So now, this is one, I would mark example 1, hey, this is similar to a quiz. I wanted to go over example 2 because it looks really similar to one that's on your test. It's very similar to that one too, but I wanted you to see what it looks like. So when you see this on a test, you're like, oh yeah, that's that example. I got really, really close. Sorry. So we have example 2. Sorry, I had it and I just thought it looked too jumbled up. Remember, mark this as very similar to one that's on a test. Or they have one on your test that is set up like this. So I have 8x cubed plus 16x squared, minus 4x. And then that's all being divided by a negative 4x. Not a negative 4x, by a negative 4x. Now we know that in order, what you want to do is what? Ooh, negative 4x, negative 4x, my life is so easy. Let me just go, and I'm done. And you would be wrong. I have to say, in my little head, I must distribute that to everything that's there. I'm going to have 8x cubed divided by the negative 4x. I'm going to have the 16x squared divided by the negative 4x. I am going to have the negative 4x divided by the negative 4x, just to make my life easier so you can kind of see what's happening here. I'm going to just make this a plus and say, hey, this up here is a negative 4x. Now it looks like okay, that looks good. Just seeing how that looked on TV or on my laptop. TV, I'm getting like an ego on. So let's look at this. 8 divided by negative 4 is going to be a negative 2. What's happening with the x's? Well, that exponent of 3 is being subtracted by a 1. But this is so everything down here is canceled out. What's going to stay on top is going to be x squared. I might be simplifying this a little too much. Let's look at what's happening here. I have 16 divided by a negative 4, which is going to become a negative 4. What's happening with my exponents? I have a 2 on the top. I'm subtracting that 1 on the bottom, which is going to leave me with an x up on the top. You all cannot see this. There. And it's like kind of crooked. All right, I'll do it like that. Now, last step. I'm going to have a negative 4x divided by a negative 4x. So this is just like, the x is divided by the x, the negative 4 is divided by the 4. What do I have left there? A positive 1. So there's one like that on your test. Let's look in your book together and let's see what we're doing next. So basically, example 3, you have, I'm not going through it because we're going to do one very similar to it on your test, or in your homework, as well as, but you have one like example 3 on your quiz, on your test. This is long division. And we could go over that one step by step. We could go over another one step by step. But I figured you might want to do that with your actual homework, so that's what we'll do. So what's happening is both of these, we were dividing that by a single term or a monomial. Well, that was easy. I just distributed that baby and went all the way through it. Well, think about what happens when I'm dividing it with a binomial or even a trinomial. Think about how much easier you had this division was. So let's say if I had 4 divided by 2, how that was really easy compared to 126 divided by 13. You remember when you got into that, you started thinking, right? Or especially when you got into that long division in 6th grade or whenever, 5th grade, whenever it hit you, and you just had this massive string of numbers. And what you ended up having to do is you had to multiply this multiple times, kind of guesstimate what you're getting. And most of you are thinking, praise the Lord, we use the calculator. This is actually easier because your numbers are a whole lot smaller. It's just basically what you're doing is you're trying to keep it in order. So you can look at example 3 very carefully. I want you to really concentrate on this table on 395 because that's telling you how to do it on your test, on your quiz, but it's a little trickier than that. Especially step 3, guys. Step 3. On your test, they ask a multiple choice question about step 3. I'm going to read that over. Repeat step 2 until the degree of the new dividend is less than the degree of the divisor, and place any remainder over the divisor and add the resulting rational expression to the quotient. That's very important. They're going to ask you about the degrees of a divisor versus a dividend, and you have to know whatever it is, then the degree of the new dividend has to be less than the degree of the divisor. So make sure you remember that for a multiple choice question. Circle that so you can come back on your test and remember that. Then I want you to look at example 5. Example 5 is on your test. It's also on your quiz. Your quiz that's over 9.5 and 9.6, only 1 and 2 come from 9.5. That's special products. Remember, if you can't remember what the special product is, even though you're using the book, you can always just do the regular multiplication to do it. But the rest of these guys, you're going to have one where you're dividing by a monomial, which is like what we did right here. You all know that wasn't that big of a deal. Then you're going to have 3 where you're dividing by binomials. One of them is where it's asking you to do some simplifying, and so technically that's going back to 9.5. So number 6 is not a division problem. Number 6 is a very complex multiplication problem. They assume that you can do it with a little bit of factoring. I did it longhand, and I came out with the same exact answer. So when you get to number 6, just say that's 9.5 or 9.4. That's multiplication, and I just need to set down and start multiplying it. Okay? If you need me to set that up, of course, remember to text me. That's the best way to get a hold of me. I tend to not look at Facebook or YouTube. All right. So let's do a couple of these problems so you know how to do it. Remember, if you need help, look back at example 3 or example 5. I want to do a couple with monomials, and then because that's on your quiz, and then we're going to do 2 word problems that are long division, okay? Not 2 word problems, 2 of the division problems that look like that long division that's given in examples. One reason why I'm not writing out and going through these examples is because it's, we have to write out a whole lot of stuff, and a lot of your time would be me wasting, trying to write out the stuff. So let's see, I've marked a couple. Let's look at 6, let's look at 7, then I'm going to do 23, and I'm going to do 31 because all of those are longer problems. We could even get rid of this if that's distracting you. There. So let's try number 6 in your homework. Remember, if you were doing traditional practice with the homework, it is 1 through, let's see here, 1 through 39. And I would say 1 through 35 or 36 would be sufficient to practice doing odds or evens, whatever your case is. 36, there's one that looks like that on your quiz. So we'll probably do 36 as well. This will be a longer lesson, but this is probably the most difficult lesson you've had in this chapter so far. All right, so let's look at number 6. Number 6 looks like this. I have 25 and AB cubed, and then I'm subtracting 35A, and then I'm going to divide that by 5A. Just remember, right off the bat, what do I need to consider? I need to go ahead and say, I'm distributing this. I'm going to divide the 25AB cubed by 5A. I'm going to divide the 35A by 5A. Don't try to get rid of it in one step right here. You will mess up, okay? It's better to distribute so you can keep that in your brain. So let's start right here. Deal with your numbers first, and it's not, nothing's going to end up being a fraction in this problem. So if I divide 25 by 5, it'll be a 5. Think about what's happening to the A's. That's like an A, 1 minus 1, which just becomes a 1. So that A is pretty much canceling out. It is gone. And then what do you have left at the top? You have B cubed. So out of that, all that's left after the division is 5b cubed. Moving on to the next one. Deal with your numbers first. 35 divided by 5 is going to become 7. The a's cancel out, or like I said, it's basically like that top a has a 1, this bottom a has a 1. You end up with a to the 0 power, which is simply a 1, and it would multiply with that 7 that we got out of 35, so it's just a 7. So your answer for 6 is 5b cubed minus 7. The number 7 is very similar, and we're going to do that one together. So like I said, these are tests. It's very similar to a test, very similar to a quiz, so hopefully we can get this. I can get my cart in the right area. So let me go back to 7. 7 looks like 7a squared times b, and then I'm subtracting 42ab squared. I'm dividing that by 7ab. Remember, just to keep myself from being messed up, I should say I need to distribute that. And that's exactly what my book is doing. It's going to take 7a squared b, and I'm going to divide that by 7ab. Then I'm going to subtract 42ab squared is going to be divided by 7ab. So right here, take care of the numbers first, or you could go ahead and say to yourself, those 7's cancel out, they're common factors. You could say the same thing with the b. The b's cancel out, they're common factors. Or you could say 7 divided by 7 is 1, b divided by b is 1. Or the other way to think about that is b, 1 minus 1 equals b over 0, and that is a 1. See, that's 3 different ways you can think about it. But basically, those are canceling out, which means all that's left on this side is going to be a, right? I'm kind of looking at it. All that's going to be left over here is a. So you have a. You have 2 minus 1, subtracting the exponents. We had that in the last chapter. So all that's going to be left is a, right? All that's left in that problem is going to be a. And this side will be a. I'll go ahead, because whatever I get from this, I'm going to I'm going to subtract it. So just say, all right, go subtraction symbol there. Now let's deal with the numbers first. 42 divided by 7 is going to be 6. Now let's deal with the letters, the common factors. So this is common. So I'm just going to go ahead and cancel those out. But my b is going to be really similar to what my a's were over here. b, I subtract the exponents, and that's just going to become b to the first power, or it's simply going to be b. It stays there with the 6. So your answer to 7 is a minus 6b. So far, all we've done is we've subtracted with monomials. And you can just do that by making sure you distribute. Now, we're going to use the division house again. And rather than trying to do that with the examples, I want you to use those examples to go back and look and see if that helps you. Both example 3, example 4, example 5 show you how to do that. So we're going to start with 23. So let's set up 23. I have 24x squared, and plus 13x minus 9, and that is going to be divided by x plus 1. So when you have a binomial, when you have a binomial or a polynomial being divided by a binomial or a polynomial, you're going to have to set up this long division problem. All right? That's just how it be. And then let's think about this. What number would I multiply to x in order to get a 24x squared? So remember, x times x makes it x squared. Remember that far. There's a little 1 in front of x right there. What would I multiply to get this? That's what you want to concentrate on. What would I multiply in order to get that right there? This isn't rocket science. I would multiply that binomial by a 24x. And look what ends up happening. If I multiply the 24x to the x, I get 24x squared. And you are going to subtract this just like a normal, screensaver, come back. There we go. Not sure if my screensaver is knocking off the camera or not. Y'all back with me? So that I multiplied the 24x to the x, and I got 24x squared. Now I have to multiply the 24x to the 1, right? We're going to multiply the 24x to the 1, and that gives me a plus positive 24x. And I can't do anything right here until I go ahead and we do some subtraction. Okay, so I'm going to subtract all of this. These two are subtract. This is you can even put here a 0. This is gone. Now I'm going to have to work with that. If I've got 13 and I subtract 24, that's like a 13 adding the opposite, which would be a negative 24. That would leave me a negative 11x. Just like a regular division problem, I would go ahead and drop down my next thing. So that's a 9, a negative 9. So let's go ahead and let's look at this one. What would I multiply? Well, right now we're concentrating right here. Look at this x. What would I multiply to that x in order to get a negative 11x? What would I multiply to the x in order to get a negative 11x? And what you want to say here is I'm not going to multiply, put an x with that one, because if I did, I'd end up with an x squared. I don't need an x squared. What I need to do is just multiply that through with a negative 11. So multiply the negative 11 to an x, I have a negative 11x. Multiply that negative 11 to the 1, and I get a negative 11, right? So now let's look at what we're doing right in that little section. So what's happening in this little section is these two, if I'm basically got a negative 11, then I'm subtracting a negative 11, or basically that's me adding the opposite. These are gone. These two are gone. So because that would be a negative 11, adding the opposite, adding a positive 11x, and they are gone. Right here, if I have a negative 9 and I'm subtracting a negative 11, that would be a negative 9, adding a positive 11, or adding the opposite, which means signs aren't the same. I subtract and I take the sign of the larger, greater absolute value number. What I would have left is a 2. Now with that remainder, I can't just leave it here. I can't say R2 like you did when you were in 6th, 7th grade or whatever. What I'm going to do with that remainder is I'm going to make it into a fraction. How do I make it into a fraction? That's a positive 2. I'm going to take this. That's going to be my denominator. And down here, I put that over there. This is your answer. Right there. It doesn't look pretty, but that's what your answer is. So we went through that one really slowly. We're going to go through 31 because 31 is unique in that we have to put some spacers, and that's what this is. Since there's not an x squared term, since there's not an x term, you have to show some placeholders there in order to make sure that you get those. Because when you start multiplying it, you might end up with an x squared. You might end up with an x cubed or something like that. So let's go over here and just talk it through with this number. So we did 23. 26, I think I said I was going to do that one, but 26 looks a whole lot like 23. So I think I'm going to go on to 31 in the interest of time because it's getting lengthy. And then I'm going to set up that other problem for you and just remind you that's what the one on your quiz looks like. So actually, if I go this way, I might run out of room. So let me just erase that and bring you back over here. And let's look at 31. So 31 is x cubed minus 27. And that is going to be divided by, I'm just going to write it like this, and then we're going to talk about what we're doing, by the binomial of x minus 3. I have to set that up in the little house. The reason why I didn't is because as I set this up, I have to put placeholders in there. So I've got x minus 3. I'm going to set this up, and I know that if I multiply x to try to get x cubed, think about what's going to happen. If I multiply something to x to get x cubed, it's going to be an x squared. So think about what would happen right here. I would end up with an x squared right there. So they're saying, go ahead and prepare for it. See, this is one, with this, you have to do some planning. And then if I multiply with an x squared, guess what the next thing would be? I would, if I ended up trying to get this negative x squared, I would end up having to basically have another x up here. So they say, go ahead and plan for that. Start going, and what you can say in your brain right now, I forgot to put the 0 there. You would go ahead and have a 0x. What you need to say in your brain, all right, I've got the power of, this is cubed. I just know in fraction, I just know in multiplying binomials that I'm going to have these powers show up. And finally, you can put in your last thing, which is a 27. So you need to put placeholders. That's basically what that means. You can read right here. You need to show a placeholder because you know that those are going to end up showing there, and if you don't have a placeholder for it, you're not going to know what to do. So it was x cubed minus 27. When we go into division, you need to show all of the degrees of those terms as you go down. It's because we know as we multiply, I'm going to end up with those. I don't know if that's there or not. I'll just do it. So what would I multiply to x in order to get x cubed? So what would I multiply to x in order to get x cubed? Well, my little exponents would add together, so I'm going to have to multiply this by x squared. So that's x squared times x is going to be x cubed. See, now looks what happens. Now you can start to figure out, that's why I had to put in placeholders, wasn't it? So if I multiply that x squared to the negative 3x squared, guess what I end up with? I end up with a negative 3x squared, and that's why I had to have that placeholder there in order to do that. I go ahead and do my subtraction right there, and I end up with, if I've got, this is going to end up making that negative 3x squared basically it's going to be the opposite. It will be a positive 3x squared. Then I look right here. What am I going to multiply to the x in order to get the positive 3x squared? Well, then I have to go back and say, I'm going to have to multiply a positive 3x. Because a positive 3x times the x will make a 3x squared. And of course, I'm going to subtract those. But look what also happens. The 3x has to be multiplied to the negative 3x. I'm going to drop down that 0x. Now you see why you had to have a placeholder. I need that 3x times the negative 3x is going to be a negative 9x. What ends up happening right there is that's going to be another opposite, right? That's going to be another opposite. So that's basically a 0x adding the opposite. What's left is a positive 9x. And now I'm going to go ahead and drop down my negative 27. I look here and I look at that x. What would I multiply to that x in order to get the 9x? So I would multiply that x, not with an x, but just a 9. I would multiply that by a 9. So 9 times x is going to be 9x. And yes, they did this in order to help you a little bit. And then 9 times the negative 3 is going to end up being a negative 27. Remember, it's not me subtracting a negative 27, it's me adding the opposite. So I have a negative 27 and then I'm adding a positive 27 to it, which means this is all gone. That's all a 0. So that basically is canceled out each other. So your answer for that one is that trinomial right there. So that's your answer. So we went through that one really slowly. If you have more questions about that, send me a text, but you have 3 examples where they go over long division for you. We've done 2 of those. So I'm going to set up one of your geometric problems that they always give you, because there is one similar to that on your quiz. They don't show you the shape, but they will ask you, what's the width of a rectangle if the area is this? Remember, you have to know that area is length times width. So I can set that up for you if you have really some big issues with that. But it looks very similar to 36. So let's do 36. What you have to know with 36, what you have to know for your quiz, is basically what is the formula for the area of a triangle? And the area of a rectangle. And the area of a rectangle is length times width. So basically what's happening right here, this is going to be a division problem. Because I know the area, they gave me the area, that was 2x squared plus 15x, and that's going to be plus 18. And then over here, I know my width, I know my length, it's 2x plus 3. What I don't know is w. So in effect, what ends up happening here is in order to figure out w, 2x squared plus 15x plus 18 is going to be divided by this binomial, which is 2x plus 3, which is going to be some long division for you. So here's one more long division problem that we can do. We have 2x plus 3. As we write this down, let's see if my variables are going down in order by degree. Fortunately for this one, they are, which means you don't have to have a placeholder. If this one was gone, you'd have to put a 0x. If this is x cubed, I would have to put some placeholders in. This one I don't have to. Now, I'm just simply going to go ahead and start dividing. I'm going to say, what would I have to multiply to 2x in order to get 2x squared? And that's pretty easy. I'd have to multiply an x to it. X times 2x is going to be 2x squared. But now what happens? X times 3 is going to be 3x. And that's going to be subtracted. So I subtract that, I'm going to end up having a 12x, right? So that's going to end up being a 12x. Drop down the 18. I concentrate on the 12x. What would I multiply to the 2x in order to get the 12x? Don't need a square here, so I'm not going to multiply a x. I just need to look at the numbers. What would I multiply to the 2 in order to get that 12? It would be 6. So 6 times 2x is going to be 12x. We are subtracting that, making sure you're still on there. You can still see me. And then 6 times 3 is going to be 18. And those end up perfectly dividing out, or subtracting to where you get 0. So your answer to it, what is width? Width is going to be x plus 6. That's what you get from that. Width will be x plus 6, or it'll be that. I just rewrote it right there. You do have one that's similar to that on your quiz. All right, so we've gone over our homework. This has been a rather lengthy lesson, but like I knew it would be. Tomorrow's lesson, I'll just be reviewing your test. And just remember, if you have questions, feel free to give me a text. That's the quickest way to answer me or to reach me. If you need me to FaceTime, I can. If you want to look up somebody else explaining this on YouTube, that's perfectly fine. What I don't want is you copying people's answers. I need to see work whenever you turn in stuff. And use the resources you have. Use this video because I'm being a little more specific to your quizzes and your tests. All right, so have a good day. Hopefully it's sunshiny. Get through your homework, get through your tests and quizzes, and tomorrow's lesson will just be me reviewing your tests. So see ya.